Have you ever gone to a place you've never been to, yet felt a strange feeling you've been there before? Or been hit with a wave of certainty that you've already lived the moment you find yourself in, even though you know you haven't? Well, this feeling of familiarity, as if you're reliving a past experience, is a scientific phenomenon called Deja Vu. Deja vu is a French term that literally means already seen. It was introduced in 1876 by Emile Boirac, a parapsychologist intrigued with psychic phenomena. At that time, deja vu was associated with the idea of past lives and experiences. Today, however, we can understand deja vu from a more scientific lens. Deja vu is rare but not uncommon. It is estimated that 60 to 80% of people experience it in their lifetime, usually between the ages of 15 and 25. Unfortunately, as deja vu can be experienced by anyone and is usually sudden, studying it has been difficult. Yet, there's a plethora of scientific theories about it that are worth looking at. In fact, it's generated so much interest that themes on deja vu have found their way into popular culture. Movies such as Groundhog Day, Somewhere in Time, Happy Death Day, Back to the Future 2, Deja Vu, yes, there's a movie called Deja Vu, and The Matrix come to mind. So, what actually causes deja vu? According to scientists, the anta lies in the brain, in memory centers like the hippocampus, where mental maps of new experiences are made and stored for later use. The reason behind deja vu, however, is not completely known and has inspired many interesting theories. One theory is based on studies involving temporal lobe epilepsy, a condition in which the neuron cell activity in the brain is disturbed, causing seizures. Studies show that people who suffer from this illness often, if not always, experience deja vu prior to a seizure. Basically, they experience a misfiring of nerve signals in the areas of the brain where long-term memories are developed and familiar sensations are identified. When this happens, this creates the illusion that the current experience has happened before. In the case of healthy individuals, they may experience deja vu as a result of a similar electrical malfunction, but in a smaller, less harmful scale. Think about a poor wiring connection that causes your lamp to flicker. Another theory is related to neural shortcuts in our brain. Our brain constantly takes in sensory information, sight, touch, hearing, smell, and taste, to create whole perceptions of everything we see. This information travels through multiple pathways to the higher cortical centers of the brain, responsible for creating thought, memory, awareness, perception, attention, language, and consciousness. In creating a memory, the information passes through short-term memory storage, then goes to long-term memory storage. However, a feeling of deja vu may occur when the information goes directly into long-term memory, bypassing short-term memory. As a result, the brain skips normal mechanisms and creates a detailed memory of something totally new, making us believe that something that actually happened a few minutes ago happened a really long time ago. The hologram theory proposed by Dr. Herman Snow suggests that memories are like holograms or 3D images of a complete scene comprised of various sensory information. A deja vu occurs when a brain tries to create a complete picture of a current event or scene, retrieving similar or comparable fragments from our long-term memory, such as the same scent, sight, or sound from previous encounters. It is this fragment of a memory experience that helps bring on the memory of a bigger scene in the same way a small piece of a hologram can be used to recreate a complete hologram but in lower resolution. The result is the feeling of deja vu when these sensory impressions from previous memories overlap with those from the new experience. According to the dual processing theory, new stimuli hits our brain and is processed twice. The second time the stimuli runs through our brain, it is mistaken for something that we are already familiar with, causing a feeling of deja vu. This was tested by Robert Efron, who discovered that the temporal lobe of the left hemisphere receives incoming information twice, directly and also indirectly through the right hemisphere. If for any reason the information coming from the right hemisphere lags even by a microsecond, the information is interpreted by the brain as a separate message. This triggers a feeling of familiarity for something we assume was from the past, but in reality was experienced just a fraction of a second ago. According to Dr. Akira O'Connor from the University of St. Andrews, deja vu is just our brain's way of fact-checking our memories and is no indication of a declining memory or memory problem. This was proved in a 2014 study by O'Connor and his colleagues, who invented a method of artificially causing deja vu among study participants. They did this by presenting study participants with a series of connected words without revealing the one word that links them together. For example, the words bed, night, dream, and pillow were presented, but the word sleep was not mentioned. Only by association would the participants think of it. After some distractions, they were asked if they heard any words starting with the letter S, to which they rationally replied, no. However, when they were asked if they heard the word sleep, the participants were conflicted as the word sleep sounded very familiar to them. Believing the word sleep was announced even though they did not actually hear it, triggered an eerie feeling of deja vu. At this point, brain activity was recorded on functional magnetic resonance imaging, and it was evident that the frontal areas of the brain responsible for making decisions, such as the prefrontal cortex, were activated during deja vu. Hence, neuroscientists came to the conclusion that the brain performs some sort of conflict resolution as it attempts to reconcile actual events with those we remember or believe to have happened. Indeed, deja vu is not necessarily a bad thing. In fact, it demonstrates how complex and amazing our brain really is. Not only does the human brain process vast amounts of information while keeping our organs functioning, it also fact-checks our memories to prevent us from misremembering people, places, and events. So the next time you experience something that you deem unfamiliar familiar, be glad and be grateful, because you've got a good head on your shoulders.